Hi friends, a very good evening and thank you for joining in today. So we'll get started with the live session itself at 7:02 or 7:03 as usual. So can you please confirm if everything is working as expected? I'm also checking everything on my phone. Okay, everything looks good on my phone, no issues. So we'll get started with, I think today's session is about network layer, right? So yeah, so we'll get started with some problems in a few minutes. In the meantime, since some of us are early, it's just good to get started. I mean, it's just good to get started with common general questions. So the question here is, should we cover optional topics of CN? So there was a change in syllabus last year. So that's why some of the earlier concepts have been moved into optional topics. You can skip them safely because the syllabus hasn't changed from last year to this year. If you have time, go through it just for knowledge sake. But in the context of GATE, you can skip the optional videos. Hey, good evening everyone and thank you for joining in. So Mayank has a very nice question, which is that he's feeling a little low, that he's not able to solve problems as well as he would like to, and he's feeling a little disappointed and things like that. Please understand that it is a very, very common thing that happens to everyone. There will be some topic or some subject in which most students struggle with problem solving. It's a very common thing. The most important task is not to get disappointed, but to double down on that topic or subject where you're struggling a little more. So I've mentioned this multiple times in the previous live sessions also. We have a dedicated video on this channel also. So debug, the most important part, just like when you write code, is to debug your mistakes. Ask yourself, what is it that you're lacking in? Again, if you're a course enrolled student, we strongly recommend that you solve the problem, go as far as you can. Wherever you're stuck, take a picture of that of the white paper where you're struggling to solve it, send it to us so that we can exactly understand where you're stuck and give you pointers on it. Very often, most of the times, people are not fully equipped to solve problems because they have conceptual gaps, or they're not able to break the question into parts, right? That's one of the most important parts of problem solving. Of course, there are also silly mistakes and all those things, but very often, look at what is being asked, apply all the concepts that you've learned, all the diagrams, equations, everything you've learned, think from first principles and see how to arrive at the value that is being asked of you. That's it. That's all most problem solving in GATE is. Please understand that problem solving in GATE is easy or medium. It's not at all hard, right? Hence, if you just come from first principles, draw diagrams, write equations, you'll be able to solve. Again, one of the purposes of doing these problem solving interactive sessions has been that to help you guide on how to think, how to tackle different types of problems. Cool. Okay, cool. I'm just scrolling down because there are a lot of questions. I'll try to answer some now. I'll surely answer more in the later part once we finish all the questions, right? I'm just trying to pick randomly and try to answer. Okay, so again, since we've been doing these live sessions on Tuesdays and Fridays, let's just continue on that schedule right now, because we're almost at the end of the first iteration, and we have what, after CN, I think we have one more session for computer networks, and after that we have COA, and then a couple of sessions for aptitude, and we are done. So let's not break that routine that we have built over the last 6 months. So this is from Ayush, who says, can I improve my problem solving skills if I focus on problems now, like PYQs and tests? Yes, Ayush. Again, as we often say, there is ample amount of practice in our test series, in previous year questions, etc. But what is important is not just solving the questions, but solving the questions thoroughly. Again, you can check out some of the videos we have done. I mention this almost in every live session. Try and struggle with that question. That's how you build problem solving skills. Give it a shot. If you can't solve it in the first go, wait for a few more hours, keep thinking at the back of your mind, try to tackle it the second time. That process of trying to figure out the solution is more important. We see a lot of students, they say, hey, I've solved 10,000 questions. When you ask them, how did you solve them? They'll say, hey, I read the question, I tried to solve it, I couldn't solve it, I just saw the solution. You're not building problem solving skills, right? You don't become a driver, a good driver of a car or any vehicle for that matter, by seeing others drive. You have to go to the driver's seat and drive the car and experience it. This is very similar, right? So you have to go through that process, that struggle of learning, that struggle of problem solving. That's the only way you build problem solving. But if you solve previous year questions, a bunch of tests, you're more than well equipped as far as practice is concerned. Because it's not the volume of questions that matters, but it's how well you have solved these 2,000 to 3,000 questions that matters. The Python very detailed project has already been added. Like it's I think about 8 hours content, very detailed, including everything from how do you solve it using basic Python, how do you use, again, it's a very interesting problem in machine learning and deep learning, and we don't assume anything in our placement prep course that you know machine learning, deep learning, and we don't use any advanced stuff. We start with some very simple concepts in linear algebra. We introduce whatever libraries are needed. We solve the problem. We also connect additional concepts like virtualization, containerization, how do you deploy these models into production, how do you design the high-level design of a solution. All of that is covered in that project. So it's fairly thorough. It takes you everything from simple linear algebra, like what is Euclidean distance, what is Pythagoras theorem, how do you apply Pythagoras theorem, to how do you deploy a model on the cloud, or how do you do something like a Kubernetes Docker sort of system. So it's a fairly big one. Again, coming back to GATE itself, the ideal time to finish GATE syllabus, again, there is no ideal time, but the earlier the better always. But if you're probably at this point of time, this is late September, try to finish your syllabus by late December or early January, so that you have roughly about those 5 weeks to 6 weeks for a good revision before you go into the examination hall. So we strongly recommend that you finish it by late December, worst case early January, so that you at least have those 4 or 5 weeks of good solid revision before you go to the exam. Okay. So Pranav says, I've completed 60% of the syllabus. Should I start mock tests? I wouldn't recommend it now. And the reason is this, because you still have 40 marks that you have not prepared for, or at least 40% of the syllabus that you're not prepared for. And if you get low marks in mock tests, you might get discouraged. So my suggestion for you is, since we still have time, remember, we are not like 1 month away from the examination, right? We still have a few more months. We have October, November, December, Jan, 4.5 months almost before the examination. So try and finish the rest of the 40%, at least finish 80-90% of the syllabus before you, I would recommend finish all the syllabus if you can, but at least try and finish 80-90% of the syllabus before you take full length tests. In the meantime, you can take subject tests, topic tests, all sorts of tests in between. Okay, cool. Okay, it's 7:04, so let's get started, folks. Good. Thank you for that reminder. I think somebody said, let's get started. Good. Thank you. It's good to be reminded so that I don't get caught up in Q&A. Again, please stay till the end. Those who have questions, I'll surely tackle your questions after we solve the problems. Okay, is my screen visible? Is everything working as expected for you? Let me just check it on my, okay. So today we are solving a bunch of problems with respect to network layer. Again, very common types of questions in GATE. Okay, so let's get started. Okay, yeah, this whole question is slightly lengthy, but just go through it. Let's get started. This is the first question, a typical 2-mark question. Very typical GATE question from network layer. So unfortunately, I can't zoom in, Mayank, because if I zoom in, people will not be able to see either the options or the diagram or the question. We try to squeeze everything into one screen, unfortunately. You might have, I think it's possible to zoom in on your phone or laptop, right? Let me just see. Yeah, I'm able to zoom in a little on my laptop, on my phone. And I'm actually seeing it on a phone, and I can read the question very clearly. Just close the chat window on the right if you're seeing it on the phone. Again, right now I will not be able to answer general questions. but I'll tackle some of these questions at the end. Abhishek, that's a good suggestion about general preparation related doubt clarification session. We'll try and conduct it sometime. We'll squeeze in time for that. That's a nice suggestion, good one, certainly. And we'll try and squeeze in some time for a general preparation, practice, examination oriented session. I'll do that. That's a good idea, actually. We'll try and squeeze it in hopefully this week or the next week. Again, if you know the concept of distance vector protocol, straightforward question. Again, please avoid asking general questions because I will not be able to answer now because I don't want to disturb other students who are still solving the question. You're most welcome to put these comments at the end. We'll happily answer. Okay, I think some people are saying none of these, some people are saying A, B, C. Okay, let's solve it together anyway in a little while. We'll inform you of the plan once this iteration is over. We will plan how to do the next set of live sessions, both for course enrolled students and for general public. From October onwards, we'll inform you of the schedule. Okay. Again, this is a very typical type of question in GATE, not just in computer networks, but in other areas also, where you're expected to know an algorithm, you're given a sample problem, and you're asked to apply that algorithm on that problem, and it says, hey, what is your answer on this? Very typical of GATE, actually. Again, the objective here is, do you understand the distance vector protocol? Can you apply it on a simple sample graph? Okay, so let's solve it together. Simple questions. Many of you got it right, some of you got it incorrectly. So let's solve it, right? So initially what happens? Let's look at it from the context of because the question says what will be the routing table of node E after the first iteration, right? So right now, how does the whole distance vector protocol work? First you initialize, right? So let's assume you have 5 nodes, right? You have A, B, C, D, and E, right? So if you look at it from the perspective of node E, initialization, in the initialization step, what happens? From E, do you have an edge to A? No, you don't. So its distance will be infinity. This is the initialization step. From E, do you have to B? No, so it will be infinite. To C, yes, you have it. And so this is your cost or distance. What is the next hop here? Obviously C itself. Again, I'm placing the costs here and the next hop here. Similarly, E to D, okay, you can reach with a cost of 17 because this distance is 17 and the next hop is D itself. E to E is 0 and the next hop is E itself, obviously. So this is what it happens. Now this is the initialization. Just like you do initialization for node E, you do it for all other nodes, right? You do the initialization for all other nodes. So since the question talks about what happens to node E after one iteration, in the first iteration what happens? All of the neighbors of E will send their distance vectors to E and E will update it. right? So what we need to look at is what are the distance vectors for C and D, which are actually the neighbors, right? So C and D are the neighbors of E. So in the first iteration, because our question is all about first iteration, right? So in the initialization, C's distance vector will be initialized, D's distance vector will be initialized. But the most important thing is in the first iteration, it will share this, and we will update it. So let's not bother too much about the distance vectors of these. Let's bother about these two, right? So from C, okay, so let's do the distance vectors, right? From C to A, you don't have any path. I'm only talking about, I'm still in the initialization right now. Please mind that. So C to A, I don't know the path yet. C to B is 18. Of course, the next node will be B itself. C to C is 0. What about C to D? C to D is 5. C to E is 11. Okay, that part is clear. What about D? So D is connected to all. D to A is 15. D to B is 12. D to C is 5. And D to E is 7. Sorry, D to E is 17. D to D is 0 itself. And D is connected to each of them. So the next will be A, B, C, D, E. Right? Again, right now we have finished the initialization. In the first iteration, because all we care now, since we have done the initialization, in the first iteration, this will send its distance vector, it will send its distance vector, right? Now, then what do? We do the minimization after that, right? This is how distance vector protocol works at its core, right? So, okay, so now what do we have to take the minimum of? So let's write down the distance vector at E, or this whole table at E, right? I'm just trying to, instead of writing it in a tabular form, I'm just writing it into a vector form. This is the distances and this is the next hops that I'll place here. So I'll have to take the minimum of these, plus this I'll have to add 11 to this, right? Because these distances I'll have to add 11, right? Because if I'm going via C to any other vertex here or to any other node, these values have to be added with 11. Similarly, these values have to be added with 17 because the distance from E to D is 17. Then I have to take the minimum. So let's look at it, right? This is infinity. This is infinity plus 11 is infinity. 15 plus 17 is 32. So what is the minimum of all three? 32, right? Very simple. And now what will be the next node here? D, right? What is the next hop? D. Similarly, if I want to fill the value for B, 18 plus 11 is 29. 12 plus 17 is 29, both 29s, and there is infinity, which is the minimum 29. And now here, I can either fill, look at this, from E, I can either go to C, right? Or I can go to D to go to B, and the distance will be the same. So it's either C or D. It's either C or D. Any one of them is valid because both of them, 12 plus 17 is 29, 18 plus 11 is also 29. Now what about C? Okay, C distance is 11. This is 0 plus 11. This is 5 plus 17, 22. So the minimum is 11 itself. Very simple. The next hop is C itself, obviously. What about D? This is 17. Look at this. This is 17. This is 16. And this is obviously 17, right? So 16 is the smaller one. So it will be 16, which means going to D, instead of going directly where the distance is 17, going via C is better because it is a shorter path. 11 plus 5. Now what about E now? E is E itself, so you don't have to worry about it. So this is what will be the routing table at the end of first iteration, after the end of one iteration. Now which of these is correct? Look at this. I think C is the right answer here, right? Because A 32, the next hop is D. B 29, next hop can be C or D. Any of them is correct. Again, till now this is also correct. C 16. 1 second. C should be 11, right? So no. C is not right. I'm sorry. Okay, so till now this is correct. This is correct. This is correct. This is correct. 11C. Oh, B is correct. I'm sorry. B is the right answer. My bad. Yeah, B is the right answer because 11 and C. Okay, 16 and C. This works. 0 and E. Yeah, B is the right answer, not C. I'm sorry. I just misread the tables. Okay, but this answer is still correct. Very simple question, right? This is all about what happens at the end of one iteration. Okay, if you do 2 iterations, again, you'll have to keep updating. Typically, the moment they ask you more than 1 iteration, right, the amount of computation increases. People who are also setting this question paper for you, right? They know that they don't want to bog you down with too much computation. Imagine if this question was not one iteration but two iterations, it will take more time, right? Because if you see, then you have to use, because A is 2 hops away, right? The whole math and the whole tracking of all these vectors, updating these vectors will become a little more cumbersome. But it's doable. Typically, you don't get such a lengthy computation in GREAT, because for that it's better to actually write code than to actually do this by hand. Okay. Again, simple, straightforward question. If you know how this system works, it's straightforward. Okay. Very simple method. Cool. Again, intentionally these options have been given a little easy. They could be made slightly more trickier, but we thought, okay, let's just get warmed up. Okay, so let's go to the second question now. This is also a very typical question of gate type. This is typically like a 1-mark question. This is an MCQ. This is again a very typical gate question where you're expected to know something about a packet format, right? So I personally don't like these questions because it's about remembering some facts, but you will encounter questions like these in gate, by the way. This is mostly about what is the information that's stored in an ICMP packet. That's what it is. Again, simple question. If you know how ICMP works, if you know the basics of ICMP, this is straightforward to answer. I see many of you getting it right. You will see some, this is obviously an easy question. Again, another related type of question that you can see in GATE is they might talk about a protocol. They might say which of these statements are correct about the ICMP protocol, right? And they might give you 4 statements and they might pose it as an MSQ, right? So these types of questions are slightly trickier because you have to know a lot of details and see which of them are correct and which of them are incorrect. Okay, so this is another type of question that we see or that we can expect to see in GATE in the future years, because MSQs are very recent. Again, these types of questions make sure that you know a lot of details about a protocol. Okay, cool. So the answer for this is B. Very straightforward. I've just taken a screenshot. From our lecture videos, actually from the course, and we actually describe this, right? When we are explaining the whole thing in the course videos, we explain how ICMP works, that the whole ICMP packet is placed within the data part of an IP packet with IP headers. And within the data part, we say, hey, what does it contain? Discarded IP packet header plus greater than equal to 8 bytes of data from the IP packet, right? This is exactly what's being asked, right? Again, we also see some examples of ICMP packets with Wireshark tool, wherein when we ping or when we trace route, right? When we ping or trace route, we see some ICMP packets which we try to showcase in the real world in the course videos. But anyway, the question is all about this part, right? So straightforward stuff, nothing very fancy, nothing very hard, easy to tackle. Okay, cool. Okay, again, a very typical type of gate question now. This is a 2-mark question. Again, a very, very typical question in gate. If you know the concept, it is straightforward to answer this. Again, in computer networks, you'll see a lot of these numerical type questions also very often, wherein you just have to apply the whole concept of fragmentation here. Okay, so most of you got it right. Some of you probably are a little confused, but it's very simple actually, right? Again, we've solved a lot of these types of problems in the course videos also. Very simple, straightforward stuff, right? So let's look at it, right? A router with MTU of 1024 bytes has received an IPv4 packet, which is much larger than this. So it will do fragmentation. This is the total bytes and with 20 bytes, right? So what is the data or payload? What is the data size? Data size will be 4020 minus 20, right? Sorry, 4040 minus 20. So it will be 4020 bytes, right? This is the payload size. The value of MF, which is more fragments bit, and the offset of the third fragment is, right? Very simple. Now, if you observe, my maximum transmission unit, including header and payload, is 1024. In this, my minimum header size is 20 bytes. So remove 20 bytes, right? So I'm left with 1004 bytes of data that I can transmit in each fragment. Now 1004, again, here the important detail is 1004 is not divisible by 8, right? The offsets that we add are basically are multiplied by 8 to get the actual the byte number, right? So here this is 1004. 1004 is not divisible by 8. So you do something like this, 1004 by 8 and take a floor. So this is 125. And that's because 1000 by 8 is 125, right? So this will be what you will keep offsetting with each packet or with each fragment basically. So now what will happen now? Fairly simple. What will be your first fragment? So let's see your first fragment. Your first fragment will be, will send 1000 bytes, right? It will send 1000 bytes plus 20 header bytes. Perfectly all right, because we can send up to 1024. Cool, no problem there. And its more fragments bit will be set to 1 because this whole 4020 bytes got fragmented into multiple chunks. We'll see how many chunks. And then its fragment offset, right? Its offset will be 0 because we're just getting started now. What about the second fragment now? Second fragment will send 1000 data plus 20 header. Again, more fragments will be 1. The offset will be, because the offset is actually 1000 bytes, but we always do divided by 8. It will be 125. The third fragment will be again 1000 bytes because we have total of 4000. So how many data we have? 4220, right? This is how much data we have. We have only sent 1000 here, 1000 here. So third one will also have 1000. These are all data, right? These are all headers. Again, more fragments is 1. Your offset is 250. Now again, what about fourth fragment? You have sent 3000, so you still have 1000 plus 20. Again, some more fragments left. Offset will be 375. Then you have the fifth packet also. Fifth packet, because 4000 are already sent here, only 220 bytes will be sent. So 220 data plus this. Again, no more fragments because this is the last fragment. And your offset will be plus, so your offset will be 375 plus 125, which is 500, right? Yeah, 500. So the question says, what is the value of MF and offset for the third fragment? You're only talking about this fragment, right? This fragment MF will be set to 1 and offset is 250. Very, very simple question. All right, very, very simple question. Of course, more variations, similar thing can be asked. I mean, an MSQ can also be formed here, which forces you sometimes to solve the whole problem. And in the MSQ, they can say, hey, the fifth fragment will have these many data bytes, these many headers, blah, 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 all that stuff. And they can give you multiple options, right? They can say something about the fifth fragment. They might also say something about the sixth fragment, which you can discard. So a similar question can be easily made into MSQs based on what is being sent in each of these fragments. Straightforward question, easy to tackle. Right, cool, this is simple, right? This is straightforward, yeah, so no major issues here. Cool, and I think somebody is asking why divide by 8, right? Because you don't have enough bits to store all the information. I think 65535, right? Some number like 2 power 16 minus 1. I think these are the total number of bytes that you can store in each packet, if I'm not wrong. And I think you have only 13 bits for each of these, for each of the offsets. You don't have enough size, and that's why you store a multiple of 8. Again, this is something that we explained in the course videos in lots of detail. We try to give as much intuition as possible on why each of these bits are like this, why only these many bits and all that, but you can't always do it because sometimes it's just an agreed upon protocol. But in the case of division by 8, it's because I think we have 13 bits to store that fragment offset, and you can't store, if you don't multiply it by 8, you can't capture the whole range of possibilities for the maximum possible MTU size. Cool. Okay. Another very typical gate question. This is like a 1-mark question again. This is about the packet formats. Again, the reason we are asking these questions is because these questions you come across these questions very often in gate. Knowing the packet formats, while some of you like me don't like to remember them, they are mandatory in the context of gate. I actually like numerical problems in computer networks, but sometimes we always have to remember things. Again, this is an MSQ for those of you who missed it. This is an MSQ. Again, a very simple question, simple 1-mark question. If you know about the options field of IPv4, you know this. I think that's about 40 bytes, right? If I recall. I think the options field is about 40 bytes. Again, very often I forget these numbers and have to go back and check it from my own notes, or sometimes I rewatch my own videos when I forget something. Happens to all of us. Especially with CN, where I don't remember the packet formats well. Again, I'm just drawing a diagram to explain a quick concept for you. Again, very nice question. Certainly remembering IPv4 packet format is important, but try and remember at least the most widely used ones like ICMP, right? It's important to remember, at least we try to cover all the packet formats that we have seen questions from in the previous years. So it's good to cover if you can. There are also some heuristics and mnemonics actually to remember these packet formats. One trick that I used to follow when I was a student, very much like you, is I used to take a white paper and draw the whole packet format a few times. And in my revision, I would always draw these packet formats because this was always the hardest thing for me personally, because I would never remember these things well. I would, like, if you give me the packet, I can explain what is what and why it is there and things like that, but I never remembered the packet format. So I used to draw these a lot of times. Again, please ask your general questions at the end. We have one more question. Once we're done with that, I'll spend good amount of time answering your questions. Okay, I think most of you got it right. Some of you probably mixed up things. So strict source routing and loose source routing, right? Or loose routing in general. That's a standard concept that's often used. That's basically saying, hey, so strict source routing is, imagine if I'm a source and I want to reach this destination. In strict source routing, you say, hey, from source, I want to go to this router R1. It mentions the whole route and it says strictly you have to take this route. Again, this is something that it's typically used by network administrators at ISPs, primarily to explore different paths, to see how much path time things are taking, right? So 6 source routing, basically the source says, hey, exactly follow this path to go to the destination. Loose source routing is very similar, except that it doesn't give the whole path. It says from the source, go to this, and then you can go to the destination. So then what happens is it goes to R1. Again, the router here will decide whether to send it to R4 or R3. So loose source routing is loosely mentioning the key nodes or the key routers that it wants to take in this path, but it doesn't give you the whole path. Both of these are very, very important optional fields, and these are typically used by ISPs and network administrators to explore different paths. So A and B both are right. Timestamp is a very interesting field. Again, this field is also there. So what timestamp does is, again, the timestamp field's purpose is this. The sender can request up to 4 IP addresses. It can mention up to 4 IP addresses. I think up to 4 IP addresses, to the best of what I recall, because I get a little confused between V6 and V4 sometimes. I think up to 4 IP addresses, it can say, hey, whenever you hit the node with this IP address, please note down the timestamp of this, the timestamp at that node. And this timestamp is typically like a Unix timestamp. And this is possible in the options field of IPv4. And this is typically used to trace the whole route. To say, hey, when I go from source to destination, suppose if I just say, hey, I want let's say I want the timestamp at the destination, right? So then what happens? There will be some path taken by this packet, right? And it will keep filling the timestamps of all the nodes. Let's assume there are up to 4 nodes, right? It'll fill up all these information and get back to you. And you can use these timestamps to trace the route both forward and backward directions. Okay, timestamp is one of the optional fields that is sometimes used, not very often used. Okay, so again, somebody is asking, are loose and dynamic the same? I think I've only read this term loose source routing. I don't know about dynamic source routing. I think it's called loose source routing, at least from the textbooks and documentation of IPv4 that I read. And timestamps, right? Let's see. Actually, I thought it was 4. I got confused whether it's 4 or 8. Again, you'll have to check this. I'll put a question mark here. I'm not 100% sure if it is 4 or 8. I thought it was 4. But again, you'll have to check it. I don't remember. So I'll put a question mark here. I'm not 100% sure. Again, these are the types of things that I often get confused with most protocols. I'll have to Google search it just like any of you, right? But anyway, I think in this context, it's not the most important thing. So A, B, C, all 3 of them are the correct options here. Okay, cool. Next is, okay, a good question on traffic shaping. Very common question. Oh, somebody, I think Google checked and it seems 9. Okay. Cool. Okay, so let's go here. So this is the 5th question. And this is a standard question on congestion control, traffic shaping, etc. Okay, thanks. Thank you, folks. I think in the previous question, you can track up to 9 IP addresses. Okay. Yeah, as I said, I didn't know this. I forgot this number because I've never used it myself. It's typically network administrators and ISPs who use that. A typical 2-mark question. The previous answer was A, B, C. Anyway, I'll solve this question. Some of you who said 9 for the previous question, right? I was just reading up. Let's just see that. I'll wait for some more time for everyone to answer. Whatever answer you get, please round it to 2 decimal places. In case you're getting a number which has more than 2 decimal places, please round it to 2 decimal places. Again, there are a few general questions. Please be patient. I'll surely try to answer these in a while. Let's finish this question and then we'll go there. Few more seconds, let's see. Okay, so let's answer this, right? So let's go into it. So this is a very simple problem, actually, if you think about it, right? Because we have solved similar problems earlier. So the key idea here is as follows, right? You have a token bucket and it says the token bucket is full to its full capacity, which is 8 megabits, right? It's like you have 8 megabits worth of tokens already, and the tokens are coming in at 1 megabits per second. New tokens are being generated into this token bucket. And now you want to send data at 6 Mbps. If you don't have a token, you can't send it, right? Let's assume your data is at, let's say, some bits level, because all of the data here is in bits, right? So, okay, so we have seen this, we've derived this very simple formula in the course videos, if you recall, which is, okay, so let me write it down. Imagine if t is the time duration, till when we can send at full 6 Mbps. Right? Let's assume that time duration that we want to find is t. So t will be plugged here. Now in this time duration t, what is the maximum packets we can send? What is the max packets? What is the max packets we can send? Right? The max packets we can send will be, again, we can just write this, that this is r, right? So, okay, so this is r and, okay, r is 1. This is the rate at which I'm getting my packets. So it will be c, my capacity is c. Again, we have derived this formula. It's very simple high school math. It will be c plus rt. This is the rate at which new tokens are being created, right? So in time t, what is the total number of packets you can send? Whatever is already there, 8 megabits, plus whatever new packets have been generated, which is r into t. Very simple concept. These are the number of bits you can transmit in t units of time. Now if this is the max packets we can send, what is the rate at which we can send these packets? The rate will be nothing but c plus rt by t, right? Very simple. And what is r? R is nothing but 1. What is c? Capacity is 8 megabits, right? So 8 megabits plus this is r, t is whatever, let's assume t is also in seconds, right? So because the question says it should be in seconds. So this will be 1 megabit by this time. And what we want this rate to be, during this interval of t time, we want to transmit at 6 Mbps. This is what we want to do, right? So if you just solve this equation now, this is straightforward, right? If you just solve this equation now, it will just simply say, okay, 8 plus, one second, sorry. So 1 megabit, okay, or else we can just write it in a slightly different notation. We can just say c plus rt by t should be equal to 6, right? So which implies, okay, 8 plus t. So this is 1, right? 1 multiplied, so there is a t here also. I forgot to write that, right? 1 megabit into t, 1 megabits per second into t. So what you'll be left with is 8 plus 1, 8 plus t by t equals to 6. Again, I'm just using, instead of this megabits, all this confusion, I'm just writing, everything is in megabits, everything is in seconds, so we don't have to worry about it, right? So 8 plus t by t equals to 6, which basically means 8 plus t equals to 6t, which means 5t equals to 8, which means t equals to 1.6. That's it. And again, you can cross-check this answer also. It's very easy to cross-check this. In 1.6 seconds, right? How much do you have here? You have 8 megabits to start with. In 1.6 seconds, you will generate 1.6 megabits more at this rate. So you're left with total of 9.6 megabits. And your output, you can send, because the network itself can send it 6 megabits per second. If your outflow is 6 megabits per second, and if the tokens that you have is 9.6 megabits, if everything goes at 6 megabits per second, it will take 1.6 seconds to completely empty this out. Right? And you can cross-check this answer very easily. So 1.6 is the simplest answer for this. Again, you don't have to remember these formulas. This is like high school math, simple, like filling of a pipe, right? These questions are typically like, there is some rate, there is already some water here. Tokens are like water, right? And there is some inflow, there is some outflow, just simple aptitude pipes and filling of tubs type of problem, right? So cool. Okay, so let's go into Q&A now. Just a second, please. Okay, So there was one nice, oh, again, just before we go into Q&A, there is one thing that I wanted to show you here. So we were discussing about this timestamp, right? My screen is visible. Just let me check. I was just opening this on my phone while, okay, so timestamp IPv4 options. So I just opened this, I just opened this lecture from Berkeley, and not very old, 2010. So if you see this, I just read this 2 minutes back on my phone. So it talks about traceroute, okay. So IP timestamp, okay, cool. It's an optional extension to IP header, okay, very nice. This is a simple lecture notes, right? How does it work? Okay, all that is cool. Does it say how many IP addresses? I read this just a minute back. 1 second. Yeah, so in this, it literally says the sender lists up to 4 IP addresses in the packet header. I think some of you who said 9, just check your source once, because most likely this will be correct, right? So it says clearly that the sender lists up to 4 IP addresses in the packet header. Again, I just Google searched quickly because I forgot what that number is, and I got this lecture slides at Berkeley, which most probably will be correct, but we can also cross-check it from other sources. IP options format. Okay. Oh, this is the actual IANS protocol. Okay, but where is our? Okay, this will be harder to read. IP option numbers. Okay. Yeah, not this. I'm looking for a better resource to quickly read this. IPv4. Okay, IP address. Okay, IP address options format. I'm just trying to quickly find out and cross-check this. Let's see if, okay, this is just about subnetting, all of that stuff. We don't need this. Okay, so again, most likely this source may not be incorrect. So it's better to just cross-check that, just to be sure, okay? Again, I also will have to cross-check that to be sure with you, but just cross-check that, okay? Cool. This is not record route, right? So this is all about IP timestamp option in the internet measurement. Just cross-check this. Again, I also don't remember this. I just quickly Google search and it said 4. That's what I recall reading of probably a couple of years back. I've also forgotten these details. But anyway, cool, no problem. Okay, so let's get to the questions now. Okay, so I have my phone here, which will be handy. So one of the questions that I just saw scanning through was is it a good choice to quit one MTech program for another MTech program? It is only sensible if the new MTech program is significantly better and gives you better career opportunities than the one that you have. I mean, in a nutshell, that's what it is. We have seen people do that. We have seen people who have gotten into not so good universities without good opportunities, and then people, in the next attempt, they got into a top IIT or IISc and jumping there, and that's perfectly all right. No problem with that. Okay, so this is a question about the interview prep course. Again, in the interview prep course, what we do is one student, like we have multiple exams that we conduct for our students. This is also part of the placement prep or interview prep course. One student perform well, and they already are at the level of top product-based companies. It's very easy for us to show that proof to hiring managers. Many of them are friends or colleagues, people whom we've worked with, and to get them recruited, because this is an entry-level role, right? For entry-level roles, because the interview prep course is designed at entry-level SDE roles. So it's very easy to do that. And the more important thing is, are you actually at the level that you can comfortably crack a top product-based company? Once you do that, I think it's fairly easy to help you with that, to help you in the last mile. So, okay, so So this is from Piyush, who says, last year I got very less marks in GATE, which was discouraging. I lost my confidence for this year. What to do now? Why are you living in the past? Why are you letting your last year performance, which is almost like what? You did this in February, right? It's almost like 7-8 months old now. Why do you make that impact your current year's practice? I think you're living in the past. Please wake up. Forget about your last year rank, because we have seen people who got disqualified the previous year and got into the top 300 ranks next year. All that matters is your effort. Please, let's not forget that. Don't get demoralized that, hey, I didn't get a good rank last year, or I got disqualified last year. Don't bother about it. The effort that you put in this year is what matters. And you still have a good chunk of time. And as somebody who is repeating GATE preparation, right? You have a lot that you've learned in the last preparation, piggyback on top of it, just like networking packets, and build on top of it. That's the key idea. So what should be the safe rank for IISc open category? Again, IISc admits in multiple departments. I think if you're in the top 100 ranks, or at least top 70, 60 ranks, you can safely get into IISc programs. But more and more, we see that IISc is also conducting, even for some of the older programs for which they never had tests and interviews, they're also conducting that because they see a lot of students lacking in programming. This is based on my own discussion with some faculty members and friends who work at IISc, and it's good. So, but if you're in the top 100 ranks, if you're a decent programmer, you should be able to get into IISc. Very nice question. This is somebody who has an alias who says, how to minimize errors in MSQs? Most of the time either unmarked or wrong. Please suggest something. My suggestion, again, if it's a numerical type of problem, my suggestion is first solve the problem, assuming there are no options. Again, I mentioned this, I think, in the last couple of sessions also, that we see more people making mistakes in NATs, then MSQs, then MCQs. Because I think the MCQ mindset has prepared you too much for elimination. Don't do that. If it's a numerical type of problem, solve the problem first and then pick the most appropriate MSQs accordingly, if it's a numerical type. If it's like 4 options are given, reread each option, especially if you're making silly mistakes. Again, most likely, if you're not getting the answer even after thorough reading, and if you're not making silly mistakes, you have conceptual gaps. For example, imagine if there is something about some let's say some IPv4 protocol, right? Suppose there is a question, which of these following are true about IPv4 protocol, and there are 4 options given. If you're missing one of them, probably you have not revised. If you have not made a silly mistake, right? Most likely those are the types of things, or you have not revised, or you don't know the concept to start with. A simple strategy in MSQ that we would recommend is take at least 5 seconds before you say yes or no. Just take 5 seconds and ask yourself, hey, can this be correct in any situation? Don't overthink it, but just think little more. Thoda sa 5-10 seconds, just give it that extra effort to make sure that you're not in a hurry when you're solving MSQs. You have to be more careful for sure with MSQs. So this is from Diksha, who says, is putting 8 hours from now good enough? More than sufficient. Again, if you have covered a few subjects till now, I think if you're putting in 8 hours for about the next 4.5 months, you're in a very good shape. Very, very good shape actually. But just make sure that you're putting in those 8 hours, like fully solid 8 hours. Like no distractions, solid effort, solid learning, debugging your problems, solving as many problems as possible. I think when people say, hey, I've put in 10 hours a day or 12 hours a day, they've not actually put in concrete 10 to 12 hours, because so much can be done in 10 to 12 hours. People get distracted here and there. Don't do that. Full focused 60 to 90 minute chunks of time, if you do it, 8 hours is very, very good amount of effort to get a lot of things done. Cool. How many marks in the mock tests is good for AR rank less than 100? Again, it depends on the mock test, because some mock tests we intentionally give them harder, some easier, based on lessons we learned ourselves from the last time. This time there will be trickier questions and things like that. But again, we cannot give you that estimate very accurately. The reason being, we have seen people who are like doing very good last year in the mock tests, who messed up in the final exam doing silly mistakes because they got a slightly trickier set. So this year in mock tests, we are adding more trickier questions. and things like that, just to prepare you better for the actual eventuality that you might get a tricky question paper or an easy question paper. But in general, if you're getting like 75 sort of marks, I think you're in a very good shape, as long as you don't panic in the exam, as long as you don't do silly mistakes there. Okay, so Milind says, can you say something about the fear of going for test series? Why do you bother about it? Again, in the test series itself, if you fear for the test series, what about the final exam, folks? Don't even think about it. As long as you've finished 80 to 90% of syllabus, go take a full test, because you'll know where you stand, you'll know what you have to improve. It is better to know what you don't know and improve that than thinking that, hey, now everything will be revealed to me. Again, this is a revelation to yourself, not to somebody else, right? Nobody else cares about your marks. Only you care about your marks in test series, right? So it is for your self knowledge, for your self improvement only. So once you finish 80 to 90% of your syllabus, go take some of these tests, mock tests, so that you know where you stand. You don't have to tell these results to anyone. Even if you get like 20 marks, right? So be it. So be it. Now you know where you stand and you know the journey ahead of you. And that's more important to improve. So this is from Madhu, who says, I'm from metallurgy background. Does IIT admission process affect based on branch? Yes, to some extent. Because there are some master's programs in some universities which only, all of them admit, sorry, my bad. As long as you're writing GATE CSC, it doesn't matter. If you're writing GATE metallurgy and then applying for some computational programs, it affects, just to be clear there. Because the simple concept there is, as long as you're writing GATE CSC, you're treated as a CSC student, because you crack GATE CSC, you know CSC fundamentals. That's all. Okay. Again, I think the test series enrollment is still open. You can just go to our website and enroll. If you see a problem, if you're not able to enroll, just call us. You can enroll it at any time. Okay, cool. Okay, so this is, does a year gap after BTech have any effect on placements after MTech? Nobody cares. Nobody cares, because you have a fresh degree. You'll be treated as a fresh master's degree student. Nobody cares about your 1 year or 2 years gap after your BTech, as long as you're graduating from a good university. Again, Manish says, I'm weak in machine instructions. What to do for this? Again, Manish, what aspect of machine instructions are you struggling with? Again, we have COA, the next subject after computer networks. We'll solve some interesting problems in COA, and actually they're not very hard, to be honest with you. Again, if you're a course enrolled student, feel free to shoot an email on exact specifics on what you're struggling, so that we can give you more personalized answers instead of general answers. But the idea, again, in most of computer organization, the easiest trick that I follow is I draw diagrams. I literally visualize myself on what's happening with the CPU, what's there in each of the registers, what's there in main memory, what's there in the cache. I try to visualize these things, especially in operating system, COA, etc., because that gives you much more like a hardware level and a physical level understanding of what's happening. And that's a trick that you can also employ. And I will also show some of these diagram-based approaches that we follow in COA extensively. We'll solve some questions right after CN. Okay. Yes, so this is Nerf, who says, is IPC tough for many students? Yes, it is. Interprocess communication is one topic that a lot of students, it's one of the harder topics in operating systems. A lot of students struggle there, and you're not alone, so don't worry about it. Okay, so this is Shankar, who says, I come from a physics background. Is it good to opt for GATE plus placement prep if I'm a GATE aspirant? Again, given that you're coming from a physics background, if you have not coded extensively, having good coding knowledge always helps, because a lot of institutes also have some form of coding or some form of interview where having some good coding knowledge helps. So if you're not very confident in coding, then probably taking the placement prep can help you solve more programming specific problems. But otherwise, if you're like, I only want gate, I don't care about others, just go with gate. You'll do pretty good yourself. Okay, cool. Yeah, so I'm working on the Hamming code related videos in computer networks. We'll hopefully add it this week. Today is Tuesday, right? Yes, we'll add it this week. That's the only topic I think that's missing. And again, this is a topic from which we got a question last year. Till last year it was not there, so we didn't add that content. It's a very short content. It will be like some 30-40 minutes. Very simple code in terms of error correction and error detection. Very simple stuff. If you've seen the other videos on network security, etc., that we have covered, it should be fairly simple to follow. I'm already working on it. So somebody says, can I purchase only full mock tests in the test series? I don't think that's possible right now. You'll have to opt to get the whole test series or not. So this is Tejas who says 3 subjects left and 4 months. So what strategy can I employ? Again, Tejas, I don't know which exact 3 subjects you still have to finish, but 3 subjects, let's assume they're like 20-25 marks, right? So my suggestion is, given that we have 4 months, finish these subjects, parallelly try to revise the rest of the subjects that you've covered long back. So that by the time you finish the 3 subjects, you would also revise the rest of the subjects, and hopefully in the next month and a half to 2 months, you'll finish everything, including revision. And by December 1st, you'll be done. October, November, 2 months, you can finish 3 subjects and the revision. From December 1st, you can fully focus on taking full length tests, revising, like solving PYQs, etc. I think that's a good strategy. At least there is no one right strategy, right? It is one strategy that we can recommend. Finish the 3 subjects, parallelly revise the older subjects, and 2 months finish everything, get to full-fledged problem solving from December onwards. Okay, so cool. Again, Aman says, I'm planning to give test series from November. Once my syllabus completes, I'm currently solving PYQs. That's okay. No problem. No problem at all. Okay, Tejas, so you're left with TOC, CD, math, aptitude. Yeah, math is a fairly important subject. So try to finish this in parallel. You can do this because these are more fundamental subjects. They're also scoring subjects. Most of these are math related. Okay, cool. How to manage final year project and gate? Again, I think the final year project expectation is that you submit it by May, if I'm not wrong, May or June of next year. So based on your partners in the project, just ask them to do or request them to do some of the heavy lifting from December onwards. Try to finish as much as possible by December. This is what I did when I was a student. I would do most of my project by November, December. December, Jan and early Feb, I would focus more on gate. I would ask my friends to do some of that heavy lifting in those 3 months. Once the gate examination is over, I'll give my full time to finish the whatever components that I had to build for my BTech project. That's one strategy that you can employ, working closely with your partners in the project. Okay, cool. Okay, so Gurpreet says, somebody said, I think 2018, somebody said that we should give 40 to 50 mock tests. Again, volume never matters. Okay, what matters is how well you have taken these tests. Lot of people, again, this is a very common mistake. They take a test, they don't debug the mistakes, they don't work on the mistakes they've made, they don't reattempt the mistakes that they've made, right? They directly go to solutions, see the answers. That way you're not building your skills. So very often in any practice, not just in GATE exam by the way, in any examination, in any competitive setup, if you want to improve your problem solving skills, it's volume to some extent is okay, but volume alone, like doing 40-50 mock tests, like I would say if you're doing 40-50 mock tests, whether versus only 10 mock tests, but you're doing the 10 mock tests diligently, thorough debugging, filling your gaps, etc., I would suggest that's better than just doing like 40 mock tests without spending time on debugging. But if you have time, if you have resources, if you have time, if you can do 40-50 mock tests with thorough debugging, with thorough analysis, going back, filling your gaps, covering your silly mistakes, all that, that's great. I mean, that's very good. Why not? Okay. Okay, so this is Vasu who says, we have 4-1 semester from Jan 20. Gate is in Feb, what to do? I mean, come on, early in the semester, your workload is going to be trivial. Let's be realistic about it. You've been in BTech for so long, you know this game, right? So, I mean, don't bunk college. Or at least like in some colleges and universities, you can take permission based on how comfortable your faculty is and say, hey, I want to take a little time off just to prepare for GATE to make sure that I do well. And some colleges give that, some colleges don't. So, but early in the semester, you have very little workload, so don't worry about it. Okay, cool. So Ishan says, I'm starting my preparation now. Should I go for 2022 or attempt 2023? My challenge and my suggestion to you, Ishan, is we have 4.5 months. Give your full heart and soul to it. Again, if you're already a decent problem solver, if you know some of these concepts in GATE syllabus, you could crack it. I'm not saying you can't, because we've seen some people do that who already have very strong foundations or good problem solvers, they can crack it. But the reason I'm saying still go for GATE 2022 is because of the time pressure. You would cover a lot of content now. And even if you don't get a good rank in 2022, it'll help you prepare better in 2023, because even in the worst case, you would have finished 70-80% of the syllabus for GATE 2022. You just have to revise it for 2023. And that's a decent strategy. Again, there are some questions about interviews at IITs. Probably this is not the forum for it. Probably we can do a dedicated live session for that, because this is primarily for GATE prep. So I would not be able to answer this here. Okay, sounds good. So yeah, I think most of the questions I've tried to answer as best as I can. I just tried to pick random questions, obviously. And thank you very much for participating. See you the next week. Again, all the course enrolled students, see you on the coming Friday. Bye-bye.